Welcome students. In today's session we will be seeing about the operation which can be performed on sets. Let us first recollect the definition of set. Set is going to be a collection of a well defined objects. So when you are taking an collection of certain elements or objects, so that all these elements or object which you are putting inside the set, you are going to follow some rule, then it is going to be called as a set. Okay, so we will now see what can be the operation that can be performed on a set. Two or more sets can be combined to give rise to a new set. So these operations that play an important role in many applications are going to be discussed below, and they are going to be as follows. Let us consider U to be the universal set, and let A and B be any two sets which are going to be there. Then A union B, we read it as A union B, contains all elements that are in A or they are going to be in B. In notation form, we write it as A union B equal to set of all x such that x belongs to A or x belongs to B. The second operation which we take is going to be intersection. A intersection B, we read it as A intersection B, containing all elements that belong to A and B. Notice over here we use A and B. It has to be in both the quantities. Whereas in union you have an or A or in B. If it is going to be so, then you define A union B, A intersection B to be the set of all x such that x belongs to A and x is going to belong to B. The third operation which we see is going to be complement of a set. You denote it by A complement or A bar or A to the power of a bar on top. You call it as complement of A, which contains all the elements which are not in A. So when you write A bar is nothing but set of all x such that x belongs to the universal set and x does not belong to A. So the elements which are not in A but they are a part of the universal set, then you call such elements as the complement of A. Next definition or the operation which we define is disjoint. We call two sets A and B to be disjoint sets when they have no elements in common. So when you have no elements which is commonly present between any two sets A and B, then the two sets are said to be disjoint. So when they don't have any common element, their intersection, that is elements which is common to A and B. So what will happen to the intersection? We notice that A intersection B turns out to be 5. So for a disjoint set, A intersection B is empty or 5. Now we will see some examples. If A is the set 1, 2, 3 and B is the set 4, 5, 6, then we see that intersection. So can you find any element which is common to both A and B? No. So if there are no elements common to A and B, we say A intersection B is 5, empty. Hence A and B are disjoint sets. The next operation which we are going to define is A difference B. You write A slash B or A minus B and you call it as difference of A and B or relative complement of B with respect to A. Relative complement of B with respect to A. So how do we define this difference? This are the containing set which contains the elements which are in A but they must not be in B. So elements which are in A but not in B is called as A difference B. So A minus B is set of all x such that x belongs to A but x does not belong to B. Now we will see an example. A is 1, 2, 3, B is 1, 3, 5, 7. Then A minus B set in which belongs to A but that must not be in B. So what is the element which is common in A but not in B? The singleton element 2. When we take the difference b minus a, what will happen? B minus s, elements in b but not in a, elements in b but not in a will be the element 5 and 7 alone. So we can see that a minus b is different from that of b minus a, so they are not the same. So difference of a and b is different from difference of b plus a. The next operation which we are going to see is symmetric difference. You write it as A triangle B or A plus circle B or A plus B. You call it as the symmetric difference of A and B, which contains the elements that are in exactly one of A and B but not in both. So when we define it as such, so it is nothing but A minus B union B minus A. It is only exactly in one of them but it must not be in both. So elements in A minus B union the elements in B minus A. So when we take an example, if A is the set A, B, C, D, B is the set C, D, E, F, then A symmetric difference B will be A minus B union B minus A. Okay. So so in which case what will be the elements over here now? Symmetric difference, when you take union, you will have A, B union E, F. So this will be A, B will be A minus B and E, F will be there in your B minus A. So you take union, so all the four elements will be there inside. Okay.